Hi everyone, I'm Rachan Gowda, TM, studying Sri Venkateswara College of Engineering, Bangalore, section Chanakya, course title Mathematics. Introduction to Random Variables. Random variables is a fundamental concept in a statistic that bridges a gap between a theoretical probability and a real-world data. A random variable in statistics is a function that assigns a real value to an outcome in a sample space of a random experiment. For example, if you roll a die, you can assign a number to each possible outcome. Random variable can be classified into two main types, discrete and a continuous. Understanding the difference between the types is crucial in probability and a statistic. Discrete random variables. A discrete random variable can take on a countable number of values. Examples includes the number of heads in the series of a coin tosses or the number of students in a class. The probability distribution of a discrete random variable can be represented using a probability mass function. Random variable, a variable whose value is unknown, or a function that assigns a values to each of the experiment's outcomes. Continuous random variables. A continuous random variables can take on an infinite number of values within a given range. Examples include measurements such as height, weight, or a temperature. The probability distribution of a continuous random variable is represented by a probability density function. Ordinal variables definition. Ordinal variables represent a category with a distinct and a meaningful order, but unlike interval or a ratio variables, the distance between the categories are not uniform or known. These variables can be ranked, but it's impossible to qualify the exact difference between each rank. Examples: education level. Typical categories might include elementary, middle, high school, college, and a postgraduate. Key differences between a discrete and a continuous. Discrete random variables are associated with accountable outcomes, while continuous ones are related to measure quantities. The sum of probabilities for discrete variables equals 1, whereas continuous variables use integrals to find the probabilities. Understanding these differences aids in selecting appropriate statistical method for analysis. Discrete versus continuous. Discrete includes discrete variables that are finite, numeric, countable, and a non-negative integer. Continuous changes are over and different values and different time intervals. Discrete can be equally visualized and demonstrated using simple statistical method. Continuous, made of a random variables which may or may not be whole numbers. Discrete can be a category containing a finite number of data values such as the gender of a person. Continuous, measuring using a data analysis methods such as line graphs, strips, and so on. Introduction to probability functions. Probability functions are essential tools in statistics and probability theory. They describe how probabilities are distributed over different outcomes in a random variable. Understanding these functions helps in analyzing and interpreting a data effectively. Probability mass function. A probability mass function is used for discrete random variables. It assigns a probability to each possible value of a discrete random variable. The sum of all probabilities in a probability mass function equals 1, ensuring a valid probability mass distribution. Characteristics: the probability mass function must be non-negative for all values of the variable. It provides a complete description of the distribution of a discrete random variable. Probability mass functions are often represented graphically with bars indicating the probability of each outcome. Probability density function. The probability density function is used for a continuous random variables. Unlike probability mass function, probability density functions do not give up probabilities directly but rather probabilities over intervals. The area under the PDF curve across the entire range equals 1, representing the total probability. Characteristics: the PDF must be non-negative across its range, similar to the PMF. The probability of a specific value in a continuous distribution is always 0. Integration of the PDF over a specific interval gives the probability of a variable falling within that interval. Key differences between PMF and PDF. PMF are discrete variables while PDF apply a continuous variables. PMF give exact probabilities for individual outcomes while PDF provide probabilities over a ranges. Both functions are foundational for understanding the different types of probability distributions. Mathematical expectation. Mathematical expectation, also known as expected value, is a fundamental concept in probability theory. It represents the average outcome of a random variable over a numerous trials. Probability mathematical expectation of random variables. The expected value is calculated as the sum of all possible values, each multiplied by its probability. Applications: in finance, mathematical expectation is used to access the expected return on investments. It helps investors make informed decisions by evaluating the risk of rewards associated with a different assets. Portfolio optimization relies heavily on expected values to maximize returns while minimizing risks. Insurance companies use mathematical expectation to calculate premiums based on expected losses. By accessing the layout of claims and their average cost, insureds can set a fair prices for policyholders. Thank you.